All right, here we go, about to check out learning target number 6, all about convergent boundaries. So we should have a pretty good idea at this point. A convergent boundary is when the plates are, of course, coming together, towards, colliding. Those are all words that we've been using for convergent boundary. And this is the busiest type of boundary. One, because there's a lot of things happening. But two, there's 3 different kinds. And remember, there's 3 kinds because of the crust interactions that can occur. We have 2 types of crust that exist on Earth: oceanic crust and continental crust. So remember, when you're looking at learning targets or any plate boundary, you are going to be asked not only what is the boundary type, so how are they moving, but also what crusts are involved. So on these blanks, you're filling in what types of crusts are there for each boundary. And remember, boundary is the spot where the 2 plates meet. So let's just look at that real quick. So we'll do our 3 types of crust for learning target number 6. So convergent, like we said, is moving towards each other, and it's the boundary, the spot where the 2 plates meet. So right here is the plate boundary on example number 1. So when we're looking at the types of crust, we're looking on either side of the plate boundary. And we can see that actually in this first diagram. This side being blue is oceanic crust. This side being land is continental crust. So on our line here, we're just filling in. This is an ocean-continent boundary. For picture number 2, again, boundary is the spot where the 2 plates meet. So left side compared to right side. Both sides of the boundary we can see are blue. Ocean boundary. And for our final, here we have the 2 plates, right? We know they're merging together. Boundaries right in the middle. So this would be a continent boundary. So convergence having all 3 crust option combinations. Now looking at this, hopefully you're recognizing that there are some similarities, but they're not all identical. So we want to look at them a little bit separate. We're going to start with this one here, convergent continent, because it's the most different. So go ahead, get yourself lined up with this picture side by side so you can fill in a few things as we go. While you're getting that set up, we do want to remind ourselves about the differences between our 2 kinds of crust. So our oceanic crust is made up of basalt, and our continental crust is made up of granite. Both of these are igneous rocks, meaning they're made from cooled rock, cooled molten rock, lava or magma. We do want to remember what's going on with densities of the crust. Basalt, the oceanic crust, you may recall, is our more dense piece of crust, while the granite is less dense. So again, density has to do with heavy and how compact the particles are. So the ocean crust is the heavier of the 2, something we want to keep in mind. So this first boundary of 2 continental plates is not super common, but it exists. And the reason it's happening is likely because there was some sort of subduction happening that gets cut off. So you can see here we had an ocean plate being pulled towards the existing continental plate. And eventually this piece of land, which was India, gets pulled closer and closer, eventually colliding into that other piece of continent. And as they pile up, you can start to see the feature forming of great mountain ranges. That's one of our biggest features here on our learning target 6, continent boundary. We want to label that. That's one of the things on your list here. This is large mountain range. And we do want to make a note. I don't think this made the list, but we do want to say these are non-volcanic. Because that subduction zone gets cut off, we don't see any magma here, right? There's no magma, so no volcanoes at this location. We also want to put in the arrows, showing that the plates are moving towards each other. And the final thing we want to mark is where our earthquakes are at. They're typically shallow, right on the boundary line where the two plates meet. So again, right at the spot where they collide, we see these earthquakes. So I'm going to keep them close to the surface. I don't want to see any down here or off to the side. Earthquakes are happening right on the boundary towards the surface as this pile of rock continues to grow as the collision extends over time. So your picture's labeled. You should be able to fill in what's going on at this boundary by just describing a little bit about what's happening and why, right? What did we say about the crust? What's going on inside the earth that creates those exterior features? You can always look back to your plate boundary details or those paragraphs to give a little scenario that you can use as kind of your research and reword it to your own words here. That's your best resource. Now our final two are ocean continent and our ocean ocean. These do have many more similarities than this one we just discussed. So as we look at these lists, we're seeing they're very identical except for one feature, and that feature is the types of volcanoes that occur. So that's going to be our only thing we're differentiating between these two. Again, good idea to be half screen at this point so you can label up the features with us and then go ahead and record your explanation here at the end. So one of our biggest features at this boundary is something called a subduction zone. When you hear convergent, this is what should automatically pop in your mind. You can see here on this diagram that as these arrows, or crusts rather, are moving together, we're seeing one go underneath the other. And that goes back to that density idea. Because the oceanic crust is more dense, it's essentially heavier than the continental crust. And so when they collide, it has over time become wedged underneath and subducts or gets pulled down in to this hot mantle material. This is our subduction zone. So you should be able to see it on your picture here and get it labeled for both locations. Right? Subduction zone is the crust being pulled into the mantle. Here it is again. I'm going to abbreviate this one because I can zoom in, but you should have the entire word subduction recorded there. Subduction zone is one of the main features at this boundary, and it really is the defining feature. It's making all the other features at this boundary happen. So this is a huge indicator of a convergent boundary and a huge creator of the other features that we see. As this plate is being pulled down or subducted into the mantle, we know that in the mantle, the temperature rises. And so you can see here in this graphic, the magma being created by the melting of this tectonic plate. This is where we call crust destroyed or recycled, because it's solid rock being melted back into magma or lava, whatever it began as. So the crust is getting recycled as it's being subducted. And again, in this graphic, we're seeing that melting of the crust create magma that's fueling these volcanoes on the surface. And again, both boundaries have the same process of subduction, melting, and volcanoes, but the names are a little bit different. We're going to see one known as continental volcanoes and one known as island volcanoes. And as you can imagine, It's really dependent on where those volcanoes are forming. Are they forming on land or on the ocean? Now, it's important to note where these are happening. This is happening away from the boundary. Remember, the boundary is the spot where the two plates meet. So we would say that the volcanoes are located off the boundary line, not where the two plates interact, but rather away from that boundary line. So again, we should have a few things labeled. Got our subduction zone. Wherever the melting is happening, you've got something about melting or crust recycled, crust destroyed. Any of those work, matching your list there. And here, hopefully you can see our two types of volcanoes. This picture on the right is our ocean-continent boundary. This picture on the left is our ocean-ocean boundary, and you can see the names of the volcanoes here. This is our island volcano, again, because it's forming islands on the oceanic crust. This is our continental volcanic arc, because the volcanoes are forming on the continent. So look carefully at your pictures and the crust that we labeled, also your lists, and label those volcanoes correctly in your diagrams. Feel free to pause if you need to make sure you get everything. Next feature here is the deep ocean trench. Again, the trench is created by the subduction zone. As this piece of crust is tilted and pulled down into the mantle, it drags along part of the continental crust with it. So we end up getting this V-shaped valley right on the plate boundary. This is known as the deep ocean trench and is home to some of the deepest spots in the ocean. The deepest known location is 7 miles deep. So both images should have a trench labeled. I like to label it with this pointy down arrow or a V to remind me, one, here's where the trench is, but also two, that it's a deep location. Earthquakes, of course, are happening at every plate boundary, but as you've guessed it, subduction does have an impact on the types of earthquakes happening here. Again, my subducting plate is being pulled down by my moving mantle material and the collision of these plates. And earthquakes, of course, happen all along any moving crust. So because that plate is being pulled downward, the earthquakes are happening at every stop along the way. We have shallow earthquakes near the surface, deep earthquakes towards the end of the subduction zone, and of course everywhere in between, medium. Now these earthquakes, because of their depth along the subduction zone, are found at varying distances from the boundary as well. Again, this is the boundary, the spot where the two plates meet. We notice earthquakes happen there, where the subduction zone begins, but also off the boundary or away, where the subduction zone ends. So we're seeing earthquakes here at all depths and all locations, again, because of the subduction zone. So these are happening all across the world. This was our bold line with the little bricks. All along the world, we have places with ocean-ocean colliding together. We have places of continent-continent colliding together. And we also have locations where the ocean collides with the continent, creating volcanoes off the boundary, deep earthquakes, and in some cases, large non-volcanic mountains. So make sure you go back, fill in your explanations, and use those paragraph plate boundaries to help you out.